Back to the big event in Timmins, Ontario, for everyone watching online. This is another installment of Tech Talks this afternoon. Our next presenter is Charles Proulx of Paradox Access Solution, and he will be talking about some mainly road building applications that are really quite innovative. Charles?
Thank you, Steve. Appreciate it. Thank you. Hi, everybody. I'd first like to thank the conference organizers for allowing myself and my colleague to put together a presentation to share with you guys. I hope that you'll find the information that I'm going to share with you informative, something new that you maybe not have heard of. Okay. I can come a little closer. Is that a little bit better? Okay. So yeah, I'll take about 20 minutes. There's going to be some information on a little bit about the company, what we do, some of the past projects that we've done that showcase some of the innovative access solutions that we provided to various sectors and industries throughout Canada. A little bit about the company. Paradox Access Solutions is a specialty civil earthworks design build contractor. We're actually based out of Western Canada, so it's great to be in the East. We don't get to spend a lot of time here, but hopefully after this we'll be able to spend a little bit more time working in the communities in and around Timmins. We've got some engineering partners that work with us at helping to come up with innovative design solutions for project-specific or case-by-case applications. We've also got a separate division that focuses on more temporary access with access mats. And today's presentation is mostly going to be focused on the innovative permanent or long-term access solutions we offer. So Indigenous relations is a big component of our business. We work throughout Canada. One of our most recent projects was actually in Quebec. And one of the things that we want to do and try to do is work with the local Indigenous communities at providing employment opportunities, at providing them training opportunities. The hope is also in the future is allowing them to utilize some of the technologies that we offer in the private sector for some of their own infrastructure needs so that they can become champions of their own assets and infrastructure in their communities throughout Canada and the rest. Here's a little video, and the owner of the company of Paradox Access Solution uses the term quite often, pictures tell 1,000 words and videos tell 1,000 pictures. So there'll be several videos throughout this presentation that they're short and they'll give you a general, good general understanding of this one in particular, our Indigenous engagement and our partnerships, and then we'll get into more project profiles and case studies.
With the partnership in Paradox. I'm also very excited with the thought that's going in for the making of the road that will be happening. The exciting part about it for me is just that the maintenance and the cost of maintenance. Our membership are clearly aware of the cost of maintenance every year on roads and maintaining roads. And I'm really, again, going to say I'm excited about what it's going to look like 5 years from now, 10 years from now, for Driftpile creation and maintaining the roads for the nation. But this project will definitely be something that I'll be looking at in years to come to see where we're at. So very excited about the opportunities that the has of Paradox and very, very appreciative of the partnership and the respect that comes with that partnership.
So we're fortunate to have many partnerships within Western Canada, and we're looking at developing more partnerships out east. We all know that Indigenous communities, generally speaking, are in a lot of regions that are remotely located. So this technology helps to minimize costs for construction on the front end and on the back end. So assets such as roads are a big component of the way of life for our Indigenous communities and getting their services and critical services up there. Although the last presentation on drones. It was very exciting to see that there's new technologies that are allowing them to get some of their resources over to their communities in a much more efficient and cost-effective manner. So a little bit about the technology, specifically the technology I'm going to talk about, which is a tough cell or a cellular confinement technology. It's essentially a bunch of hoops or plastic cells that confine aggregate that are inside the cell to give added strength to that aggregate inside the cell. It helps distribute the loads that are applied over top of it to minimize those loads that go down into the weaker subsoils that generally don't have the same bearing capacity that, let's say, sub-base layers or base layers have. It's a cost-effective solution for both paved and unpaved roads. Some of the benefits of this technology, it allows for different types of aggregates to be used in road building that traditionally wouldn't be used. So for example, sand sometimes isn't normally used for structural layers in a road. If you take sand and confine it, you can increase the strength dramatically. So the analogy we often use is take a bucket of sand, flip it upside down at the beach, and then try to stand on that bucket of sand when you move the bucket. You're just going to sink further into that sand or that material. Now, confine that same amount of sand in the bucket, you can put a car on there and it's not going to move. So it increases the strength dramatically. We're allowing for a much smaller right-of-way or footprint because we're now increasing various structural layers within the pavement to make it thinner. So sometimes if you've got limited real estate to work with, you've got the ability to build a much smaller right-of-way or a smaller footprint, which requires less aggregate, less hours, less processing, less equipment time to actually put it together. It's got a lower environmental impact because we're not moving as much material, so maybe minimizing the amount of trucks on the road. We're minimizing safety, potential safety risks associated with transport of equipment and materials. And it helps, like I said, provide protection to those lower, weaker subgrade soils. This video is a little bit of a 2.5-minute visualization of how the technology works.
The best things are built to last. When it comes to highly trafficked roads and load-bearing job sites, reliability is key. Tough Cell by Paradox is an NPA Geocell reinforcement solution that can be used to build roads and surfaces that last as long as you need them to. Tough Cell is an expandable web that spreads out to form a honeycomb for vertical pockets. Pockets are then filled with a granular material, like local sands, recycled asphalt, or mixed aggregates. Once full, the cells are then compacted. With the conventional road structure, the load weight spreads downward and in all directions. This can form ruts and cause degradation of the subbase layers. On a road built with tough cell, the granular material presses against the sides of each pocket, and most of the vertical stress is distributed horizontally. The material doesn't shift, the road remains strong, and any weak spots on the ground beneath the tough cell layer are bridged. Tough cell can be used to build mountain roads, but also rare. Paths, earth stabilization, and paved and unpaved infrastructure. Compared to a conventional road, tough cell requires less material and a shallower depth of material to fill in its geocells. Local materials can be used, so there's no need to incur the cost of bringing in gravel or sand from somewhere else. Tough cell builds take less time, and if you're more aware, and need less maintenance, resulting in a dramatic reduction in CO2 emissions. Tough cell is a smarter, stronger, more responsible choice for your next build. So when you need to be on solid ground, choose Paradox.
Our engineering partner, Stratum Logics, we've got a principal engineer named Dr. Snap Pokerell that works with us. And he came up with this slide doing his doctorate on utilizing geocells in flexible pavement designs. So on the right-hand side, where it says unreinforced, you'll see what they're showing is a pressure bulb for a wheel load being applied on a road. Obviously, the darker direct loads right underneath the wheel are the most severe and intense. What we're trying to do is minimize those forces from reaching the weaker subgrade soils. So if you can minimize those forces from reaching those weaker subgrade soils, generally speaking, you're able to extend the life of that pavement and reduce long-term maintenance. We often say roads wear down from the top, but they fail from the bottom up. So I know certainly I've spoken to various community members in Timmins. They're like, oh, you got road solutions, that's great. We've got these potholes everywhere, what can you do? Unfortunately, with those problems, now you're left with, you can either do a full depth reclamation, which means you excavate all that poor material out and rebuild it from scratch, or you just keep putting Band-Aid solutions in with patching it, and it'll continue to happen. So this solution will allow you to provide a longer, more durable road that requires less maintenance, and when there is maintenance required, you're trying to avoid that full depth reclamation, so you just need to surface dress it on top. It's used in multiple applications, from road building, slope stabilization, railway ballast foundations, intermodal yards, reservoirs and landfills. Sometimes you have limited real estate and other jobs or other things that I mentioned earlier where you don't have too much space. So in a landfill, you can increase the side slopes of your landfills and keep the material stable inside the buckets when it's on a really steep slope. So that's some of those applications. So I'll go through a couple of project examples now. This is an example that the University of Alberta was working on with one of the major oil and gas exploration companies in northern Alberta. So this is an example of a typical Tier 1 haul road for an open pit mine. As you can see, based on the number of traffic loading, the anticipated weights, the road that they had to build had to be 4 meters in thickness. So there's a requirement for various types of well-graded aggregates. And what we were able to do is now take, on the upper picture here, or in this design drawing, you'll see the standard design. We're able to cut that overall thickness down from 4 meters down to 2.65 meters. On top of that, we were able to use a lot of their overburden materials that they would normally dispose of inside of the cells, so they can use what would normally be trashed and use it inside the cells to actually build the road. So worked out really well. Here's an example where I just got 4 pictures to show kind of through the stages. One of the benefits of the technology is that you're able to build directly over top of existing subgrades where you don't really need to do a lot of work over top or excavation of poor subgrade materials. So the top, I guess for you guys, left-hand corner of the picture would be a picture of the creek where they're building this temporary road. The second right below that is where we just put in a layer of geotextile to keep the separation between the backfill material that we're going to put inside of the cells and the existing subgrade materials. We used 2 layers on this particular design to reduce the overall aggregate thickness and to meet the structural requirements that were needed for the anticipated loads. And the picture beside the creek is our team or our technicians installing the first layer that will fill with sand. It'll consolidate and utilize the strength of the organic materials, or muskeg, inside of that flexible pavement design. And then down below that, that's the final structural layer that they'll place, and there'll be a final lift of well-graded aggregate or gravel for safe traction on that road. Here's a pictogram of some various applications that you can use for bridge abutments, retaining walls, numerous applications. This is a project that we did for one of our partner clients in northern Alberta. They needed to build a permanent access route to an old compressor station that they were expanding to meet the demands for natural gas transmission throughout the area. We had to build an 11.5 kilometer road into the area to allow them to access the compressor station that we also expanded as well.
So we are building a road for a very important client. The way we're going to do that is we've got to cross Muskeg in a pretty sensitive wetland area. To do a conventional road build here, you would have to excavate an incredible amount of material. And, I don't even think it's possible, because how do you get out there with equipment to excavate that material? We're using Geocell technology to build this road. With our methods and our materials, we can start at the edge and just start building the road and pushing it out.
big challenge for sure has been the weather. We've had almost max rainfall to start activating tracking.
Without our laborers, this wasn't possible because not everybody can do it.
Our client is a very important client. We know that this road is leading them to a very important project.
It's like a feeling
Really good.
So that was a really good project. This is the most recent one that I spoke of earlier, which was done in Quebec. Similar project, but unique circumstances on the project. We were limited to a specific right-of-way requirements because there was housing communities, plus other private lands and utilities in the area. So they also had very weak underlying clays that could be susceptible to major settlement over some of the loads that they were anticipating. So it was a unique, challenging job. Here's an example of kind of the conditions that we were building directly over top of. So we built a 4.5 kilometer access road to the compressor station so they can increase the distribution of their gas, natural gas systems with their partners here. So here you can see the utility lines that we had to deal with on the left-hand side. And on the right, we had another private landowner they had to consider. So we're putting in our first layer, backfilling it. This is another shot of the estoppel pad where they're actually going to be tying into the main line. Aerial view of it being done, and it was, again, one of the benefits of this job was that we eliminated the need for them to excavate any of the natural materials. So reclamation on the back end would be easier as well, because they didn't have to re-import some of the natural materials or organics that were in place. This one's a project that we're very proud of. We were part of the team that was able to put the Hudson Bay rail line back into operation in 2018. 2 years prior to that, there was some major flooding from some rain events that washed out numerous sections of the line, and we were asked to help in coming up with solutions that allowed us and allowed the community to get land access travel back to the community. So we were tasked with repairing numerous sections of the line to allow some traffic to be used on that rail line again. Here's a quick video of that. One of the really challenging things about that job was that the logistics, just to get aggregate out on site, was very challenging. There's only one way in, and that's on that rail line. So we were able to utilize a lot of the washed out material that had spilled out back into the cells. We had on-site geotechnical engineers maintaining and ensuring that the gradation was right. So it was a big savings for everybody on the re-establishment of that line. So this technology has been validated in numerous academic papers throughout North America and internationally. So I just want to make sure that it's something that has been utilized numerous times in various municipal government regulations. Yeah, that's the gist of it. If anyone has any questions, I'd be happy to answer them. Thank you very much for your time. Yes.
You got everything else covered?
Yes. So permafrost is actually, I'm glad that you asked that, Steve. We're actually working with the University of Victoria right now on doing some studies on the effects of permafrost. Early indications are that it's a big improvement in allowing that permafrost to be insulated and keeping it frozen. So there'll be more to come. We're just waiting for some of that research information to come back from our academic partners, but early indications are that it's going to be a significant improvement to help insulate that material from freezing. or from thawing, excuse me. Yeah.
Beavers,
Yes.
just redone all of that.
Okay.
You're in the middle of nowhere, the beavers will be up.
Mhm.
How does that system stand up to that immense amount of water that is flowing?
Right, so the special polymer that's used in the production of the material, it's inert. It's not going to harm the environment or the natural environment. For beavers to get access to it, they'd have to dig through, because all that material within the cell has to be compacted. Again, it's dependent on the project that we're working on, the specific project design parameters, must be compacted to a certain density. So generally speaking, if it's a two-layer system, let's say the bottom construction layer that we often call it, is compacted to 95%, then it's buried by another 6 inches of aggregate, and then our next structural layers over top of that compacted to 98%. So it's tough for the beavers or any other natural environments to get into it. Now, in saying that, geometric design considerations must be maintained. So there always needs to be positive drainage on the pavement design that we're working on. So water's draining properly, culverts are installed in the right places to maintain the movement of water away from the cells. The aggregate source inside the cells should be free draining and should always allow for the water to freely drain out of it. Because we don't want that to freeze inside the cell and do what water normally does when it freezes and beats up pavements and concrete and everything else. So, yeah. Hope that answers your question.
I was also thinking in terms of flooding,
Yes.
because washouts are generally
Right.
how it stands out, how that structure stands out.
Mhm.
It will happen in remote areas. I was looking at that, and I was just thinking of all our remote lines. Cap that one little wee tiny one, and it was north of the day after.
Right.
Heard of it. That looks like they happen in 300 years. And it looks like a perfect application.
So, maybe we can work at working with various design communities and industry partners at finding solutions to minimize the beavers from building their dams in and around the hydrology or hydrogeology systems that are in place to ensure the water movement's doing what it should and not have a culvert that's smiling, for example. That's not going to work. You don't want a happy culvert. You want the culvert to maintain its place and its elevation so that it drains water appropriately away. And if there is settlement, the benefit of this technology is it allows it to be uniform, not differential, which would often create that, smiling effect, or the elevations invert, or the outlet elevations of those culverts from being impacted. But very good question, Steve. Yep. Anybody else? Thank you. Thanks, Steve.
Thank you very much. That was an excellent presentation. It was fun to watch, and I can only imagine as you continue to improve your technologies, you'll be able to jack it up another level.
So, hope so.
Yes,
Yeah,
yeah,
thanks,
I can just see going through those swamps. But it looks like there's hope on the horizon. Well, thank you, everybody. That concludes that particular presentation. We have one more to go. So again, have a coffee. If you're online, we'll be back in minutes once our next presenter is all set up, live from Timmins, Ontario.